Hello everyone. In this experiment, I'm going to explain my machine learning experiment on random forest and add a boost of algorithm. In this experiment, we use penguins dataset to perform classifications. We will go through data pre-processing, model creation, evaluation, and performance comparison using different parameters. Let's start with a random forest. The first question is to read the dataset. First, we implement the required libraries pandas and read the CSV file into a data frame. This data frame contains penguin details like bill length, bill depth, flipper length, and body mass. We use head to display the first few rows and understand the data. The second one is data pre-processing. Next, we perform pre-processing. We handle missing values using mean imputation. Then we convert categorical value into numerical using a label encoding. This step is important because machine learning model cannot work with the text data directly. And the third one is like selecting features and targets. Now we separate the target into independent variable x, bill length, bill depth, flipper length, body mass, dependent variable y, species of penguins. This helps the model learns how input features related to the output. And the fourth question is like a splitting the data set. Next, we split the data into training data 80% and testing data 20%. Like training data is used to train the model, and the testing data is used to evaluate the performance. And the fifth one is to assign like a setting parameters. We define different parameters: number of trees 50 and 100, maximum depth 2, 3, and 4. These parameters helps us test different model configuration, and this is output. Sixth one is to create a random forest. Now we create a multiple random forest model using a different combination of parameters. Each model is trained using the training dataset. This helps us compare which combination gives better result. And the seventh question is model evaluation. Next, we evaluate each model using accuracy, precision, recall, F1 score. These matrices helps us understand how well the model performs. And this is the output you can see. And the eighth question is to confusion matrix. Finally, we display the confusion matrix. This shows how many predictions are correct and incorrect for each class. It helps in deep analysis of model performance. And next question, and here you can see the confusion matrix outputs. And next one is add a boost. First question, as usual, like now we read the data set. We move to the second algorithm, add a boost. We again load the data set using pandas. And the second one is like pre-processing. We repeat the process, handle missing values, apply label encoding. This ensure the data is ready for modeling. And the third question is feature selection. We select the same input feature and target variables as before. This allows fair comparison between random forest and add a boost. And the fourth one is like training and test split. We split the data set again into training and testing sets. This ensure consistency in evaluation. And the fifth one is setting parameters. For AdaBoost, we define number of estimators like 50 and 100, learning rate 0.01, 0.1, and 1.0. Learning rate controls how much each model contributes. And the sixth one is like the creating an AdaBoost model. We create multiple AdaBoost models using different parameter combinations. Each model is trained on the training data. Evaluation matrices. We evaluate the model using accuracy, precision, recall, F1 score. This helps compare performance across different configuration. And as you can see, here are the output like estimation, accuracy, precision, recall, F1 score. And the eighth one is like confusion matrix. Finally, we display the confusion matrix for each model. This gives a clear picture of a precision result. As you can see the result. In conclusion, for this experiment, we learned how random forest and AdaBoost work. Different parameters affects model performance. Evaluation metrics helps in comparing models. This experiment helps in understand ensembles learning technique efficiently. Thank you.